Okay, good morning, one and all. Today we are going to solve a real world problem. The main problem is training a machine learning model in production usually takes hours of manual data cleaning, algorithm testing, and hyperparameter tuning. So, even worse, if our web server handles everything from training to testing, it crashes the API for everyone else. So today I'm going to solve this problem by building an asynchronous enterprise level distributed AutoML platform from scratch. So this is the project I have built. Okay, coming to myself, I'm Praveen Kumar. I'm a software or full stack backend engineer. uh, okay, coming to the project, enterprise level AutoML platform. So the high level architecture I have not mentioned in the Redmi. So I will tell you what is the high level architecture. So this is just not a simple Python script. It's fully containerized distributed system. So there will be mainly four pillars. The one is our API gateway, the fast API I have used, which is useful for handling incoming web requests, file uploads, and status polling. And a message broker, which is Redis, acts as a queue holding the ML pending ML jobs. So Redis can be used for the message broker as well as the caching system. So asynchronous engine, this is the core engine of our project, which is nothing but Celery, a background worker that pulls jobs from Redis and executes the heavy ML without training the or blocking the web server. Okay, next coming to the experiment tracker, which is our ML flow. It contains all the logs and not logs, metrics, and it provides a beautiful UI. I'll show you while the practical demonstration, and logging for model parameters, cross validation, and binary artifacts, and the machine learning stack, scikit-learn. So main library in machine learning, and the FlyML, which is our auto ML engine. Auto ML means auto machine learning. So FlyML is an fast and lightweight machine learning model developed by the Microsoft. So alternatives like auto scikit-learn can be used well, but I have used FlyML, which is can be best fit for containerized application like Docker, with the Docker, and XGBoost, LightGBM, and SHAP, and feature importance are mainly useful for AI explainability. So instead of giving the answer, the AI explains why I make a decision and how it will be impacted. And wide data profiling means for statistical reporting. So instead of generating or writing the HTML code, it will generate a beautiful web page. This is how my project structure. So I have explained the main four pillars of our project. That's it. Coming to the standard features in this project are: one is automated ensembles. The platform doesn't uses or train single models. It uses FlyML, which is fast and lightweight ML, to dynamically build a complex voting and stacking ensembles within a strict time budget. So within the given time, it will be uh, ensemble techniques like voting or popping, everything else stacking done within the given time budget. And AI explainability, it also mentions why I am taking this decision instead of just giving simple answers. It automatically calculates that SHAP value, and also SHAP means shapely additive explanations. So businesses know why exactly the AI made a decision, and along with that, after the picking the best model, it can be generated its own Python script for deploying into its own microservice. So and also writes its own Docker file instantly as its own microservice. Okay, now get into the practical demonstration. Now you understand this complete architecture with concepts only. I will explain with real world examples also. So let's get into a practical demonstration, or should we go into real time example? Okay. So imagine a highly popular fast-paced restaurant. This is a real-world example. Here the waiter will be fast API, which is asynchronous. When a customer orders a complex seven-course meal, the waiter does not go to the kitchen and cook it. So what the waiter will do? he will take the order and receives and receive and gives a order ID. So what the waiter will do, API will place that job ID in a queue, which is our nothing but message queue readies. Yeah, this is our order ticket trail. It is our message blocker. So this is a temporary storage in memory storage queue that holds the pending jobs until someone is ready to process them. So who will process the jobs? Our asynchronous engine, I think, but celery worker, the chef. With the chef locates the ticket rail, pulls the next order and starts cooking. So in the background, the chef, our salary worker works. The process takes time as we need to done all the things. For example, data profiling, ML training, hyperparameter tuning. All this thing has to be done by the chef. So it will take some time. So that's it. The chef operated independent of the waiter. As the waiter process is to just take the job ID and place them in a messaging queue or redis. So it is independent of the API, our waiter. So this is the asynchronous background processing. The kitchen logbook, which is our ML flow tracking. While cooking, the chef write down all the ingredients and things he used. So it can be used for future reference or anything, or how much salt they use, the oven temperature. In this project, the ML flow will store the details of which is a ML model used and which is the best model and what's the accuracy score. All the things will be stored. I'll show you the UI of this ML flow also. So this is ML flow. Okay, let's get into the source code. Okay. Okay, let's get into the practical demonstration, or do I need to explain this? Okay, let's me explain the services. Nothing but our containers. One is Redis, messaging queue. So who ports? One is host port, another one is the container port. So host port need to be our system port, and container port is our the port which is inside the Docker container. So it need to be listen the request from host port to container port and process them. So that's why they need to be same. And the health check command redis CLA with respond with request ping. It will be responded with a POM. Inside the container, this will be taking place. And the ML flow, which is built by using a custom, not custom, Python image. And the volumes are nothing but they will store the data between the containers restarting. So once the containers are restarted, the data may be lost. So that's why we are creating volumes. The volumes will be stored outside of the containers. So the data will be stored between the restart. And the command to install the ML flow inside the ML flow container. So another example why I used an database. So in machine learning there will be multiple models, and a number of models. So instead of using volumes that are stored in our hard drive or hard disk, it will be easy to query from the database. For example, a typical example can be select the model from the DB where art score or accuracy is greater than some 90%. So it can be easily fetched from the database. And the API, which is our waiter, built from the custom Docker file created, and the main.py will be the source code for this API. So mainly there will be three endpoints. One is for uploading the CSV files, raw tabular data with post request, and the endpoint is slash jobs with status code 202. I mean, once the user has been uploaded their CSV file, it need to be written status code 202, which is accepted. So it will be assigning a job ID using UUID module. I mean, not module, package, module. Okay, it's a module. It will be assigning. I mean, it will generate an ID, universal unique ID, and after that it will be saving the file, user uploaded file with job ID, and it will be processed to the celery queue once placed in the redis. So app dot get job ID. So the what's the state of the task? It can be easily fetched from. slash jobs get endpoint when the endpoint not endpoint when the job ID input is given, and the result of the task state it will be return the task dot. That's a API service. I mean API container. Now the worker asynchronous engine behind the which works asynchronously. So it will be custom Python file written, not Python Docker file written. It will be built by using this file Docker file. So the task dot file, the file which is responsible for managing all the tasks. For example, model picking and sending the data to the ML fly ML. All the things will be done this asynchronously in the background by this task.py file. So there will be multiple users. I will show you that too also once the practical execution completed. So that's it. This is the Docker compose file with all the containers. Okay, let's start the containers. I hope Docker will be useful for running the applications at anywhere or any system, because in industry there will be a topic called this working in my system, not working on another system. So once the application is Dockerized, it can be run at any system. So there will be no dependency drift. Okay, let's see Docker is running or not. Okay, Docker is running. Yeah, all the containers are working. So let's get into it. So this is the workflow when a user submits a CSV. The uploaded file will be sent to main.py file. It saves the file to this container. It's a job ID using UUID, and pushes a task ticket into Redis. Immediately returns do not be accepted to the user. The APS job is done. Now the celery running in the background constantly watches Redis whether any job ID or tickets has been there. I need to process them. It's a celery's job. Pulls off the queue and starts executing the machine learning pipeline. And user checks the status, it will be able to return the what's the status of the job. So that's it. This thing everything has been explained. Okay, there will be multiple stages in the machine learning pipeline. Okay, first let's get into the, yeah, everything is working. Fast API will provide us an automatical documentation, which is the Swagger UI. So all the endpoints will be visible here. So I'm going to upload the CSV file. I have created a custom CSV file called dataset.csv. Okay, I will show you what's here in the dataset. So this is the dataset I have used. The dataset consists of mainly four attributes, four features. One is age, income, credit score, and whether the loan is approved or not. I will represent it using binary 0 or 1. So this is the dataset I will be using. Okay, the target column that need to be represented is approved, whether the loan is approved or not, and the task type is classification, and the time budget. Let me set it to 15. So in the first of this presentation, I told you to within a strict time budget. So this is the strict time budget. Yeah, the job is, I mean, the user has uploaded the document. Now it will be returning a job ID. So this is the job ID. So since I have uploaded the file just now, the status has been set it to pending. So you can also check the job status using your job ID. Yeah, the job status is still pending. So we need to wait for 15 seconds and check whether the job has been success or failure. So meanwhile, I will show you the MLflow UI. Not 3000, it's running on 5000. The job ID BD. Yeah, this is the job ID. So this is the MLflow UI, which will be helpful for knowing all the metrics. So metrics best CV loss it has been using. And the parameters we have given task type approved and not task type, target column approved and task type classification, and the time budget we have given in the API by the user. Okay, after all this happens, so the job has been succeeded and the model name is known as RF, which is nothing but random forest, and the best score it has given is 0.16, 16%. So these are the details, I mean the job results. Now get into the features, I mean artifacts were generated. So the data profile. So this is the data profile of this job ID. All these things were generated by using Y-data. Y-data profiling is helpful for generating these type of reports instead of writing the our HTML code. Y-data profiling will do this job for us. It will generate the histogram, common values, and extreme values. So that's it. This is an example. And feature importance. So yes, how features are selected in the FLAML training log. There will be multiple iterations because of selecting multiple models and the best score given. So it will take multiple iterations. So this time we have used random forest, and before that we have used extra tree, and before that XGBoost and LGBM. So considering all these ML models, it will pick the final one which will be giving better accuracy score. For classification tasks, for regression, it will be giving the best R2 score. So this is the leaderboard CSV file and SHAP summary. There will be two aspects. One is feature importance and another one is SHAP value. Feature importance is selected based on the global wide. I mean, you can see it from a manager's view. Considering all the users examples, I mean users data, they will be considered if the loan has to be approved or not. Coming to the SHAP value, it will decide whether to based on the customer's view. It will be helpful for considering the loan or not. For example, looking at the John's, let me take an example of John. Looking at the John's row, it will check for the credit score. Okay, age, income. Income is about 50,000. So credit score, I mean, approval rate has been increased to 50%. and the age is 25. Okay, good. It has been increased to 75%. So loan improvement has changes to 75%. Now the credit score becomes 5, for example 250, like that. It has been down, so the credit score has also been decreased to 50% or 25%. So the loan will not be approved based on the SHAP will works. Let's look at the summary report also. So this is the executive summary with the job ID and the status cycles. And winning algorithm is RF, which is nothing but random forest. Accuracy is nearly 83%. So we have already seen the profile report. This is the global feature importance and the SHAP local explainability. Leaderboard we have already seen. So that's it. Once it has been generated all these artifacts, it will also generate its own Python script file to deploy as its own microservice in the production. So coming to the deployment model, it will generate an automatic Docker file, and along with that its main.py file, and also saving the best model along with the requirements for txt, so it will be useful helpful for production to deployment. So that's it. This is how this process, I mean this project works. Now get into the task.py file. I mean how all those things will be done in the background by our celery worker. So importing necessary modules, for example OS, for file manipulation, or not file manipulation, for reading environment variables or something, we need to use OS modules. And celery app, this is. And wide data profiling for profile, I mean reporting, we'll be using wide data profiling. And FlyML, which is nothing but a fast and lightweight ML developed by Microsoft. So that's it. And a scalar scikit-learn pipeline, because in a pipeline there will be we'll be pushing multiple models at a time and selecting the best model from the pipeline. So one is, first thing is loading the data, and setting this ML flow with experiment name and URI. I'll show you that. So this is the one we are setting. Run name created at all the things, and generating data profile, preparing the data for machine learning. So the FlyML settings we are going to set by manually. The time budget will be taken from the time budget at user uploaded time, and the metrics accuracy if the class task type is classification and sort. And ensemble true means we'll be using techniques like stacking or popping, for example, not for example, to ensure the best model. And the FlyML training will be storing in the file. Yeah. And the artifact generation. And another thing is leaderboard, generating the leaderboard. Now the main thing is AI explainability. Why I make a decision, the model will tell us. So for generating all these things, we will using matplotlib for drawing this the diagrams or graphs, bar graphs. And SHAP summary plot. SHAP is for local instance, I mean customer view. And summary report. The deployment package, we have seen how the model has generated its own deployment because of this code. So we are setting a folder type called deployment, so that's why it will be creating a deployment. And copying the model with the title name model.pk. So this is the one we are setting model.pk. and the requirements.txt file will be generated based on this. And we are with open with this is all the Python code. W means write mode, and f dot write requirement content. We are writing the requirements.txt for all these things, and generating the Docker file. We need to generate the Docker file too, and a Python script for uploading. So this is the complete task.py file. Our celery worker works in the background. So the configuration will be written in this celery underscore app.py file. So that's it. We have seen the artifacts and how the model has been taking decisions, everything else. So that's it. Thank you.